Hi everybody. So I just thought I'd do this quick little handheld camera video. As it turns out, I was getting ready to do the next project and I was messing around with the speaker dummy load, which is this board here that I made in another video. And I went to switch to 4 ohms and realized that one of these switches was worn out. And they just don't hold up against how much current some of these high-powered amplifiers can put through them. So I decided to dispense with this and put something in that's going to be a little bit more robust. So here, I think I've shown these in previous videos, but here are the dummy load resistors. And they're each 1,000 watts. This one and this one are 8 ohms, and then these 4 are all 4 ohms. So we basically have an 8 ohm and 2 4 ohms on each channel. Each one is 1,000 watts. They're non-inductive, so they're really good for the application that we're using them. And what I thought I would do is I'm going to make a switching system over here, right next to the resistors, so that we can switch between 4 ohms, 2 ohms, and 8 ohms, and be able to not have the switches wear out again. I'll show you what I'm going to use here. So right here is a rather high quality electrical mains switch. As you can see, it's good for 20, well, if it'll focus, it's good for 20 amps at 120 or 277 volts. So you can actually switch the power between a 480 volt line and the neutral, because from the 480 to the neutral in a Y-connected 480 three-phase system is 277 volts. So this can handle quite a bit of power. And the really nice thing about this is because they're designed to handle high power, they have to have extremely low resistance. So let me hook this up to the Kelvin meter here, with the Kelvin leads, and I'll show you what kind of resistance these contacts have. Okay, I have the Kelvin leads connected to the switch, and when I turn it on, that's how many ohms it is. So it's actually less than 1 milliohm. It's very, very low resistance across this switch terminal. Now here's the thing. We have 2 4 ohm resistors and 1 8 ohm resistor. If I put 2 4 ohm resistors in parallel, I'll have a 2 ohm resistor, and we can dissipate 2,000 watts. If I have these 2 4 ohm resistors in series, then I will have an 8 ohm resistor at 2,000 watts. Then I have an 8 ohm resistor at 1,000 watts. But what I want to be able to do is I want to be able to switch these 2 resistors between series mode and parallel mode. And then I can switch them in parallel into this one. So for instance, if I put these 2 in series, that would be 8 ohms. Put that in parallel with this, that would be 4 ohms. But it would be 4 ohms at a whole lot of power, as you can see. In addition, I can take these 2 and switch them in parallel, and that'll give us a 2 ohm load if we want to really test, kind of stress test an amplifier. In addition, I can take this 8 ohm and this 8 ohm and put them in parallel for 4 ohms. I think I already said that. So I want to have the options to do that. The problem is when you want to switch 2 resistors between series and parallel, the least amount of contacts on a switch you can do it with is a double pole, double throw switch. And of course, most main switches only come in 2 very common styles. One is going to be the single pole, single throw switch. The other is going to be a single pole, double throw switch, which is better known as a 3-way switch. But what we need is a double pole, double throw mains switch. They do make them. Let me show you one. So here it is, and you can see there's 3 terminals on this side and 3 terminals on this side. And to make matters even neater, it has a center off position. So when it's in the middle, none of the contacts are connected. When it's up, the two switches are in one position, and when it's down, the 2 switches are in the opposite position. So what we can do is we can use this to switch these 4 ohm resistors not only in and out of the circuit completely by having in the middle section, but we can switch it between series and parallel. Let's look at a little schematic I drew to kind of show you how we're going to do all this. So here it is, and I'll put it up on the screen. But I'll just kind of show you here, but I'll put the actual picture of it up on the screen for you. But you can see here's the two 4-ohm resistors, and here is the double pole double throw switch. So when these two things are sitting in the middle, they're not connected to either one, so it disconnects the resistors altogether. When it's switched in position 1 up here, it's going to be 8 ohms, and that's going to be your series. And when it's switched down to the bottom here, it puts them in parallel for 2 ohms. And then you have the 8 ohm resistor sitting over here by itself, and it has its own little switch to bring it in and out of the circuit. And then here are your 2 speaker terminals that would go to your amplifier. So you see how that works. Now I originally had a provision for this to be able to switch this in and out, but when I found that one switch that had the center off position, you really don't need this one anymore. So that'll be an extra position that we could use for something later. And what I might do is put another 8 ohm, maybe put an 8 ohm resistor, in series with everything, and use this to kind of jumper it out, so we could actually have a 16 ohm or something like that. But I don't know. That's down the road. So that's what I'm going to do. I'm going to wire these up right now. So one box is for the right channel and one box is for the left channel, and all these are coming into here. We're going to use 12 gauge, multi-stranded oxygen-free copper. Yeah, and this should be a much better dummy load that I don't have to worry about those little cheap toggle switches wearing out or overheating the contacts from high current and things like that. So let me get some of that done and we'll be back. Okay, well, we got it all wired up, and hopefully this is you can see it. So here is the 8 ohm resistor, number 1. This is the first 4 ohm resistor, which we're calling number 2, and resistor R3 is this one here. And this wire going into here goes out to the terminal strip, or the barrel connector, banana connector, whatever you want to call it, on the other side. And here's our DP-DT switch for the two 4 ohm resistors. And here is the SPST switch for the 8 ohm resistor. So I have this turned off, and I have this turned off. And according to our schematic, if this is in the middle position, which is off, and this one is open, we should have basically an open circuit. So going around to the front, we have the terminal connected, and you can see we have an open circuit. Okay, if I switch this one on, I should have 8 ohms, because I'm switching in the 8 ohm resistor. Switching this one in right here, if I can quit shaking around while I'm moving. And look at that, 8 ohms right on the money. Now turning this one off and putting this one into the first position, just like that. And we have 8 ohms, which is the two 4 ohm resistors in series. Now if I switch this one all the way down into the 2 ohm mode, that's going to put these two in parallel. And look at that, 2 ohms. Now if I switch this one again back up to 8 ohms, and I turn on the other 8 ohm and put them in parallel, that puts this in parallel with this, and this is switched into the 8 ohm mode right now in series. And as you can see, we have 4 ohms. And you can see how accurate these resistors are. And for the very last position, if I switch this down to 2 ohms and leave the 8 ohm here in the circuit, it gives us about 1.6 ohms or 1.68 ohms in this case. So that would be good for looking at some of these really high-powered car amplifiers that are 1 ohm stable. So again, because this switch had a center off position, I don't need this third switch. So this right here is not even in the circuit. This is a straight piece of wire here. So I'm going to I'll put a switch in there, but it won't be used. It'll just be blank, not connected to anything. I'll get this together and we'll get some labels made up and we'll see what the finished product looks like. By the way, this switch is made by Leviton. You can see it right there if it'll focus. I don't know if this will really get a good view of it or not. And it is a model. Let's see if I can see where it is. It actually has a part number. There you go. It is a Leviton model 1288. 1288. And expect to pay about $53 for one of these. They can be anywhere from $40 to $60 depending where you buy them. They're very expensive because they're not a really common switch. And being 30 amps and very ultra low resistance and DP/DT, they're expensive. Now these other ones, these single pole ones, these are Leviton also. So there you go. These are only about $3 or $4 a piece. They're not real expensive. Okay, and there is the finished product. So we can turn 4 ohms, 8 ohms, 8 ohms that way, 2 ohms, and then this switch is just extra for later on. And there you go. Looks good. So now we should have some reliable dummy loads for the amplifier, and I don't ever think I ever have to worry about these switches wearing out again. Those cheap toggle switches just weren't cutting it. All right, that's it.